In this lesson, we are going to discuss an alternate form to the equation of a line. We are going to discuss the form called general form. In the past lessons, we used the form y equals mx plus b, such as y equals 3x plus 2. This is a handy way to write the rule because we can see the output is isolated, so we can easily just input x and calculate our output. This form also really quickly we can spot the slope of the line, and we can easily identify the y-intercept for graphing purposes, etc. However, a lot of times equations will be given to us in general form, which is ax plus by plus c equals 0, where a, b, and c are some values, and x and y are still our input-output. They're just rearranged in a different way. So that is what we're going to discuss today. For example, we have 5x minus 3y minus 15. This is in general form. We don't know the slope of the line, we don't know the y-intercept, but we could figure it out, and we've done this in the past. How did we do this? We rearranged the equation into slope-intercept form. So we isolate the y. We keep the negative 3y on the left, and then the 5x and the negative 15 need to move to the right-hand side of the equation, so they switch signs. And then we divide by the number in front of y, and then we have our y-intercept form. So now we could graph this line by plotting negative 5 on our y-intercept and counting out slope from there. But today we're going to go the opposite direction. What if I give you slope-intercept form and I want your final answer in general form? Can you rearrange an equation so that it's in general form? Now there's a couple things I need to tell you about general form. You'll notice that the x always comes first, then the y, the order of the alphabet. C will be the constant term, the term without a variable. Also, another important part of general form is there will be no fractions. So we need to make sure our final form is in this order with no fractions. One last little piece is the first term, the leading coefficient of the x term, in other words the value of a, cannot be negative. So I'll show you what I mean using these following examples, and we'll go through that. Y equals 5x minus 1. You'll notice it equals 0. That means I don't want any terms on the right-hand side. Now, just to keep it simple, we'll just always follow the same rule. There's other ways we can do it, but we'll just move everything that's on the right-hand side over to the left-hand side and leave nothing left on the right. I will do them in the order of x, then y, then constant. So the 5x and the negative 1 are on the right side, so both of those will need to go to the left side. The y is already there, so it remains positive. There are no fractions, which is great. However, the first term is negative, so I need to multiply each and every term because we have the property, since it's an equation, golden rule of algebra, whatever I do to one side I can do to the other side, and I keep it balanced. So I'm going to multiply both sides of the equation by negative 1. In other words, I'm just switching the signs of each term. So now I'm in general form. So that's transferring to general form. However, sometimes my equations have fractions. So the first thing I do is, if the fraction is negative, I transfer my negative to the numerator, making sure it's in the numerator. Now, again, using the golden rule of algebra, I'm going to multiply both sides by 4. So I'm going to multiply the left side by 4 and the entire right side. That means each and every term is going to be multiplied by 4. You'll notice in the middle term here, the 4's will cancel, and this is how we get rid of the fractions. So now I have 4y equals negative 3x plus 20. Now, again, I follow the previous steps. I want nothing left on the right side, so the 3x I transfer first. It changes signs. The 4y is already there, so it stays, and the 20 transfers signs over. And again, I have general form. You'll notice I do not know the slope or y-intercept properties of this. I would need to convert to slope-intercept in order to know the slope and y-intercept. This just is a nice final way to write the equation of a line. What happens when there are two fractions? I have a 4 and a 6 I don't want. Well, you take the LCM, the lowest common multiple between both 4 and 6. 4 and 6 can both become 12. That is the LCM. So I multiply both sides by 12. I multiply the left side by 12 and each term on the right side by 12. Now I'll see some canceling. 4 goes into 12 3 times, 6 goes into 12 twice. I now continue on. 3 times x is 3x, 2 times 1 is 2, and I continue as before. Nothing left down the right side. 3x becomes negative, 12y is positive, and the 2 becomes negative. Oops, I don't want a negative, so I multiply through by negative 1. And now I have general form. Last but not least, what happens when I have decimals? How can I figure out what to multiply by? You can just think it through, or you could change each decimal into a fraction. The 4 is in the tenths place value, so it's 4 over 10. Reduced is 2 over 5. 0.75 is 75 100ths, because 5 is in the hundredths place, or we could just know, I know 0.75 is 3/4. So we replace our decimals with our fractions, and now we figure out our LCM between 5 and 4. Our LCM is 20. They both can become 20. So we multiply each and every term by 20. And again, we'll notice we have some canceling. The 5 goes into the 24 times, the 4 goes into the 25 times, and we multiply it out, and we get 8x minus 15. Leave nothing on the right. I could, if I wanted, move just that to the right-hand side, because 0 equaling everything is the same as everything equaling 0. That is absolutely fine, but we'll just keep going this way since that's how we started. Switch the signs appropriately. Oops, don't want a negative. So, whoops, forgot to switch that sign. Minus 20y minus 15 equals 0. Switch them all to the opposite. I now have general form. So, in summary, converting from slope-intercept form into general form, no fractions. Do that first. Eliminate fractions. Then move all terms in proper order to the left-hand side and make sure the x term is positive. The other thing we need to talk about is an intercept. What is an intercept? The x-intercept is basically a point that intercepts the x-axis. So the x-intercept is the value of x when y is 0. So to find it, you basically substitute 0 for y and you find x. Vice versa, the y-intercept is where it's intercepting the y-axis, so you substitute 0 in for x. And that will find the y value. So let's practice. The first one, to find the x-intercept, you want to plug in 0 for y. So you're going to get 0 in place of y. We now have an equation with only x, so we can solve for x, and we get x is 4. In other words, on my graph, we know that that point exists. X is 4 when y is 0. Now to find the y-intercept, we need to plug in 0 for x. Anytime you plug in 0 into a term, the term becomes 0. And so I'm just left with y equals 8. So that tells you that it is crossing the y-axis when y is 8. And those are the values. We could also, you notice, use this to graph a function. It's exactly the same as creating a table of values. The y-intercept is plugging in 0 for x and calculating y. The x-intercept is plugging in 0 for y and calculating the x. What about the special cases, our constant functions, y equals 3? Whenever you have a special case or in which you have a constant function, I use visualization to solve. I graph the function. Where does y equal 3? Y equals 3 there, and it's a constant function, so it's horizontal. It equals 3 at all of these points along this line. And then I just visualize my intercept. My y-intercept is 3. My x-intercept is, oh look, it's parallel to the x-axis. So there is no x-intercept. It will never intercept the x-axis. X equals -4. What kind of constant function is that? This time we don't have the y value. So I take a look and try to figure out all the places where x is -4. And I visualize that. So that's going to be a vertical line because all of these points contain the constant x coordinate -4. So again, I visualize the y-intercept is, this time it's parallel to the y-axis, the slope is undefined, so the y-intercept is none. And the x, don't ever write 0. If you wrote 0, you'd be wrong because 0 is the origin, and 0 is an intercept, so you have to be specific. So x-intercept is -4. And there you go with intercepts using constant functions and general form. Let's practice one here. We could use the intercepts to graph, or we could use slope-intercept form. If we wanted to use the intercepts to graph this, you would just plug in 0 for x and figure out the y value. And again, when you're plugging in the 0, it wipes that out, and so you get -4y equals 12, y equals -3. And I can plot that point, 0, -3. So that's the y-intercept because I plugged in 0 for x. So let's go ahead and find the x-intercept by plugging in 0 for y. And so that's gone, so I really have 3x equals 12, x equals 4. So basically x is 4 when y is 0. An intercept will always have one of the coordinates being 0. So I can plot that point, and now I can easily graph a line using that property. I like to graph this way when I convert this general form into slope-intercept form, and I get a decimal for the y-intercept. Or I get a difficult one to graph because the y-intercept is not an easily plottable point. So what I do is I like to have this option when slope-intercept isn't that great of a form. How would I have done this if I asked you to graph using slope-intercept form? Well, you would have done what we did before, and you would have isolated the y, so moving terms across, dividing everything by -4, you're going to get negative over negative becoming positive. A positive divided by a negative becomes negative. You are going to, oh look, this is going to work out great. -3 is my y-intercept, up 3, right 4. Since it's a positive slope, I go up 3. And yes, it's the same line, so you always have options for graphing general form equations. Either one is fine, but on a test, if I specify, you should use the appropriate form. Last little piece, vertical and horizontal lines in general form. Remember, vertical and horizontal lines only have one variable. So, write the equation of a line in general form given the x-intercept of 1. Let's erase that. The x-intercept of 1 means x is 1 when y is 0. That's what that means. So if that's the x-intercept right there, and there's no y-intercept, you know it's going to be vertical. That wasn't very good, but you get the idea. So